That's so cool. I can literally watch that one.
Yeah, I know, it's awesome.
Hello there and welcome to this extremely scientific episode of the Slow-Mo Guys. We're in a lab.
Yeah, for once, actually.
For once, our lab coast makes sense.
Yeah.
GE actually flew us all the way to New York, to their labs, which is awesome.
Interrupted my holiday and everything.
Yeah, they want us to film a bunch of their technologies, so we're going to start with this video. We've also done 2 other videos on GE's channel, so be sure to check those out. Check those out.
Yeah, so this video we've got some super hydrophobic material. It's man-made, it acts similar to a lotus leaf, so if you want to squirt some water in there, it shows.
See?
So yeah, the water
right
runs off. Yeah, and that's hydrophobic material. This one here is man-made, and we're going to test that with some food colour and water, and get that in slow-mo, see how it looks.
The way it works in nature is that there's actually tiny nanoscopic hairs on the plant which trap a layer of air, and that causes the water just not to be able to penetrate. There's basically just bouncing off air that are trapped.
Yeah, and this is the man-made version.
So we're going to take the phantom and we're going to take a macro lens and get some super close-up shots of the way water reacts on a super hydrophobic surface. Science.
Wait a minute, I'm just pouring out some food colouring into this container here. We're going to pour it onto the surface all at the same time, and hopefully
Get a nice collision, yeah?
get a nice collision, sort of splooshing, if you like.
Yeah.
Good word.
That is the technical term.
Yeah, I believe so.
So we've got red and blue.
Red and blue, hopefully we'll merge and we'll get some full shots. How much time done?
Let's just first just do a pour.
Okay. 3, 2, 1.
Oh. I've honestly,
Look at that!
I've seen robots with worse timing than that.
That's ridiculous. Literally perfect. I like how it sort of just looks like a flower, it spreads out completely and
Yeah.
it just bounces off.
So weird.
It's really cool.
Alright, so now we're going to try that again, but backlight it so we can see through the liquid.
3, 2, 1, shut.
So another thing that happens is that iron filings in water, when the magnet goes up to them, it's very easy to differentiate the iron filings from the liquid. If the iron filings have been shaved down to a nanoscopic scale, you basically get metallic liquid.
Like Terminator 2 basically.
It looks like the T1000.
It is so cool. Okay, so here is the ferrous liquid. So it's got the nano-sized iron filings and iron particles in there. Okay, and this is a magnet. You're going to place the magnet down the test tube like this. Okay, and then lift up the liquid towards the magnet and watch as it
Give it a go.
It gets attracted.
See how it like indents before? It like pushes down and then shoots up. And you end up with basically a magnetic ball.
That is really cool. And look,
so good.
it even sort of attracts to other bits of metal as well.
Yeah.
You can see how that works there. Yeah?
Yeah, and keep the plate angled slightly towards the camera, not away.
Okay. Ready?
Yeah. Whoa. Alright, it's good.
I just love the way that it Sorry. There was no need for that.
I'm sorry.
This was literally brand new.
That
I'm actually
has literally been in use for about 30 years. Well, I hope you enjoyed that video. Can't really go wrong with liquids, they always look good. So be sure to follow us on Twitter and also check out the 2 videos we made for GE's channel. One is called MEMS and the other is called Cold Spray. And if you're intrigued by them, give them a click, give them a watch.
Check them out.
Guess we better get escorted out of here.
Yeah. On guards and everything.
Yeah.
Why don't they trust us?
I don't know.